I just went through all the characteristics associated with individual needs and requirements. And now I'm getting into the presentation on the characteristics for sets of needs and requirements. 1.5, why use a text form of communication? That goes into detail what the advantages are. In the needs and requirements manual, we have both a discussion of the advantage of textual versus using models to derive that. Pros and cons of both. It's really two sides of the same coin. Neither is sufficient. Both are necessary. In this guide, we're focusing on the textual form of needs and requirements. If you want to use another form, at least you would expect that form to have the same characteristics that we're going to talk about here. And there's reasons for each characteristic. For each characteristic, the way the Guide.which requirement is written, we have a definition of what we mean of the characteristic. We have some rationale why that characteristic is needed. Then we provide some guidance to help you meet that characteristic. Then we have a trace to the rules that help achieve that characteristic in section 4. We have a trace to attributes that help that characteristic. And those attributes are defined in detail in the needs and requirements manual, but we've added a one sheet listing those attributes and their names in the appendix to the Guide.which requirements. So you don't have to be going back and forth. And then a big change from past versions of the Guide.which requirements is this trace to activities concept of needs and requirements manual. In doing that tracing, I listed the paragraph numbers in the manual, but there's analogous paragraphs in the guide to needs and requirements. That's a new thing. So we're saying that to achieve the characteristics, the rules help, but they're not sufficient. They're necessary, but not sufficient. And so again, the dependencies and apparent overlap between several characteristics, we see like if it's ambiguous, it's also not verifiable. And so there's the overlap between those. But we found that just being able to focus on that concept has value. Define all of them. Those dependencies and overlaps we talked in detail throughout the guide. Mike, you mentioned yesterday something about first principles. Can you elaborate on that?
If you consider that a requirement expression is an element of a set and that set is contractually binding, then it follows, and particularly since we verify each requirement, that each requirement should be contractually binding. So then, if you follow that argument, then each requirement expression should be a mini contract in and of itself. That is, it should say what's needed, how well it should be performed, how it's going to be verified. And so then that's the little mini contract. And if that's the case, then the characteristics of that contract need to be the tenets of a fair contract, at least as they exist in common law, anyway, in English common law. A contract's not fair if both parties don't understand it equally. And so therefore the requirement statement has to be unambiguous, that it has to be singular. It's got to be a single contract which is being undertaken, at least be able to be broken down to be atomic, that it has to be feasible. It's unfair in common law for me to contract with you to fly at the speed of light, knowing that that's impossible, even if you're dumb enough to sign up to that. So in common law, these characteristics are effectively derivable from first principles, if you like, that if that requirement expression is to be a fundamental element of a contract, whether it's a soft contract between one part of an organization and another in terms of the developer and the stakeholders, or across an adversarial contract between a customer and a contractor, it's the same principles. Does that make sense?
Yes, thank you. That's what I was looking for. When you look at it, a given characteristic, this is what it looks like in the definition, rationale, the trace to the rules, trace to attributes, and the trace to the sections in the needs and requirements manual, the concepts, activities that help contribute. And the definitions I gave yesterday for requirements, we had two different things included in the definition. One was that they were the result of formal transformation from something, and they were agreed to obligation. And that's what Mike was referring to in the contract part. And so there's certain characteristics that are characteristics if you did the formal transformation right, and then there's other characteristics that are more aligned to if it's an obligation, if you're going to agree to do it. So we got 3: complete, consistent, and for some reason we didn't have correct as a character. That's one thing that we've added is C15 correct. A set of needs and requirements to stand alone, such as sufficiently describes the necessary capabilities, characteristics, functionality, performance. I should be able to build the system based on those requirements. A set. There's nothing missing from the set. And part of that is also, remember, the quality, the requirements deals with the quality of the set of needs. So hopefully we address the missing part as a first step. But still, when you're doing the transformation from needs into requirements, you should specify an incomplete set of requirements. that don't adequately address all the needs. A set of needs and requirements incomplete if there are needs and requirements missing. Missing needs and requirements can result in significant shortcomings in delivery product. They're not sufficient to meet the needs. So integrated set of needs must be sufficient. Talk about an accurate representation of life cycle concepts and the sources they came from. And then the same statement is for the requirements, is the requirements must be sufficient and accurate representation of the integrated set of needs. The goal is to clearly communicate the needs for a system of interest be a minimum set that is necessary and sufficient, no more. And that goes in with getting the bloated sets of requirements where we go beyond necessary and sufficient. We add extra stuff. We talk about that for the individual requirements, but it applies to the set too. Necessity and sufficiency of requirements that can only be determined with respect to the set versus requirements to the entity and set of parent requirements to the entity. It also addresses possible conditions and experience, including anomalies, safety, security, resiliency. That's something I've added that's not currently in there, but I'm going to add that. A lot of work that we're doing in collaboration with the Systems Security Engineering Working Group is that people you do use cases, but they introduce misuse cases and loss scenarios. That goes beyond nominal and off nominal. In a system security world, if you haven't talked about those other aspects, then you're going to have missing needs and missing requirements. It's really hard to determine when you look at a set of to determine what's not there. We have checklists and different activities that help us make sure we didn't miss anything when we're doing this. So we have to do additional analysis of possible conditions to ensure that required behavior, the conditions consistent with the stakeholder needs. And that's a problem. The stakeholders probably have not done that level of analysis. The project team to do that analysis to make sure that we have, because typically what we get from the stakeholders is not complete and inconsistent. For each system of interest, the integrated set of needs represents a complete definition of stakeholder expectations, goals, objectives, lifecycle concept, drivers, constraints, and risks to be mitigated, whether explicitly stated or undocumented implicit expectations. And one of the problems are interacting with stakeholders, they have explicit things they communicate to you, but then there's implicit. That can really get you in trouble. Is that the possibility of implicit is there. So we have to deal with that and how we interact with the stakeholders to uncover those to make sure our set isn't missing anything. The project team can't say, well, you didn't say that. And the system validation, if you haven't met an expectation, they're not going to like that solution. But sometimes they'll focus on the functions and they won't say, well, we assume you're going to build something that's high quality, so they never say anything about it. But there's the expectations you're going to do it. They're not going to say anything about all these different loss scenarios and misuse cases, but you need to address those things.
So wouldn't that be coming from FMEAs and risk items, the loss cases and other?
Some people do function analysis based on the design, but you can actually early. So when you do an assessment of functions that inputs and outputs, and so you can do an assessment. What's a nominal input and what's an off nominal input? What's a nominal output and what's an off nominal output? The FDA part, you do what they call a use FMEA, a user FMEA. If the user is interacting with the system, what could go wrong that could cause harm to the user? Or in case of like a standard cycle, what could cause harm to the patient?
I never heard of that. I've heard of functional FMEA.
Yeah. I've worked with other organizations that do high FMEAs. The interface is very most effective analysis. It's off-nominal input, it's nominal off-nominal output. So there's a whole bunch of things. But there was another term that lady used that was a different type of analysis.
SGR.
Yeah, something like that. She said it was different than FMEA.
And anyway, before going to FMEA, you could just identify normal mode and failure mode, or perhaps several failure, and just by identifying that this set of what we expect when everything goes right, this set of requirements, what we expect when things goes wrong, normally wrong, and this is when we are in catastrophe. And that example of the GtWR, there's another thing. So even without going to FMEA, you can start to consider the question of normal and abnormal failure.
But the concept of misuse cases and loss cases really isn't addressed in that. That's a different concept that's been introduced by in the safety of people for that. And then the resiliency working group that has a whole bunch of other things that we look at that's closely related also for on that. Refer also to the needs and requirements manual and needs and requirements for additional guidance for completeness rules. Yeah, that help. R29 on really deal with sets of requirements, or a lot of the other rules are on the individuals. And attributes, yeah, having the rationale, transparent states and modes, that category can help. And lots of activities have to do with completeness. Have we done all this upfront work? That's what all section 4 is. And section 5 is verifying and validating and have a good set of needs. All the things section 6 about defining the requirements, that transformation process. And then that was the verification validation of that. Section 8 is what we call design verification validation. Design team is looking at it and say, oh, but you didn't address this. Is the stuff missing?
Question before you know, but my question is generic, but well, like, did you work on the question of the translating of variants in the cases where we are model based? Because we are making model based things and doing requirement engineering model traceability to models, using models to capture the need and even modeling the requirements as properties, as their function following. That brings a lot of paradigms, so I would be very interested to see if there was already.
So it depends on the modeler. If you're focused on basically behavior and functionality in the conceptual world, and that's all you do with your models, then you're not addressing probably a lot of the things that apply to the physical world. And a lot of the abilities apply to the physical world, not so much the conceptual world. In that case, you're going to end up with an incomplete set of requirements if you base it strictly on the model. So one of the ways of organization, we talk about form, fit, function. Models address the function part pretty well, and maybe the fit, because that involves the interactions. But form is a physical thing. Some modelers don't bother with the physical world. That's
talking about the physical world, I can give a just practical example on which we worked recently on it. When we are going to be taking into on the physical constraints, is available energy, pressure, etc., just on the load and what the structure is able to handle and things like that. There are really great examples where doing a lot by linking the requirements and the requirements following the physical architecture. And also by modeling the requirements, that could be a way to have a digital continuity from this initial analysis of the design phase down to even the MDAO analysis, sizing optimization, and that type of thing. But this question of the modeling requirements is, of course, obvious when we're talking about the expected behavior and functional one. I'm really convinced that there is a large range, and we are really exploring it. And I'm really interested on the question also, but in the working group with my folks on that, and roughly in model quality objectives. And one point is when we think of model for requirements engineering, that raises a lot of things. We rely, of course, on the guide, but there are things to translate, potential, a lot of things that could be complemented. And on the question of completeness, then we could look at the completeness for the scope of a set of requirements and then in the block which is associated, and is the set of requirements fully covering what we expect that's expected in the block. What we expect in the block, is it fully stated with requirements? So are we going to need 100% coverage on both sides? That could lead, for example, to have a modular view on this question of completeness. And even the question of a completeness of traceability parameter or consistency with the parameter naming. So that's why I was asking that large thing to share.
And one problem that we have is that right now, the system now doesn't include the concept of needs. And the needs from a different perspective is problematic. And also, where do you cross the line from design output? When you're doing modeling, you start getting into if-then else's and all that, you started writing algorithms and you drop between, you went into the design of the system. So where do you draw the line? This is a common question that we're getting asked. Monday it was brought up on our pre-session. And so that's going to be one of our separate exchange cafes that we have in our monthly meetings is we're gonna, what was it called?
The word used was requirement models.
Okay, so that's gonna be a separate thing, and so watch out for our announcements when we schedule that and address that, because a lot of people want to have that same discussion. It may be that we end up with the people that are really versed in that subject, write a separate guide addressing the requirements and models. Some organizations say the models can go so far, but you still need a requirement management tool to manage the complete set. And then you have the GtWR that links the two together. So if I had a new requirement in the model, it's automatically added in the requirement management tool. If I edit one of the other, it's automatically reflected in the other. And so you get the best of both worlds that way.
And you have those standards, your type of integration,
Yeah.
I'm really interested on that, and I really log myself on my profile to be part of the group, so to teach you and potentially to share things with me. For example, modeling.
But even before you get to MDSC, I mean, take old school when we did functional flow block diagram, still doing that functional analysis to get your requirements in, right?
The need and requirements manual. I have a whole bunch of analysis stuff there.
Right.
That's based on the old school functional flow by diagrams, and then taking functional flow by diagrams and then to a textual description diagram. That's all included in the needs and requirements manual. And then how that's implemented within the SysML model is. Yeah.
Right.
Okay.
So this is just SysML and MDSC tools are just doing that same visualization and doing that complete functional analysis to get to your functional requirements.
Yeah.
And very on the question, I think we should more in digital engineering whatever. And there could be overall models like SysML models. Yeah, really a lot of range of tools.
I know some other organizations that the products they produce aren't that complex, and there's no way they can justify even thinking about any SysML modeling, but yet they can buy Visio. Okay, so then they can go and use a Visio tool or something like that to do all that work, and that's appropriate for their system.
And at the end, I think the question of concepts, what the modeling language and the example of completeness on modes, failure modes, normal modes, and off modes, what we expect when the system is out of power. Just stating that if we do the capture of the need model base, we have to take into account this question of modes. And if we don't, it's not potential.
Yeah, theoretically, you can define this in a tool and language agnostic so that somebody can implement it using Visio, somebody else can implement the same thing using it.
And that's their approach because each requirement manual, the way it's explained, anybody should be able to understand the thought process without having to know any language tools or know any tools. Everything I did in PowerPoint. Consistent, again, we have the individual requirements, and a lot of that meant, using consistent in all your requirements, but consistency in the set. Now we're talking about the relationships between needs and requirements with other needs and requirements in the set. So unique, does it not conflict or overlap with some others in the set? Units and measurement systems of the same set. I told you the story earlier where you a requirement document I could immediately see it was written by 5 different people, and because they use 5 different names, they might even, God forbid, use more than one set of units. Violates all the consistency things that we're trying to do. So the language used in the sets is consistent, the same words are used throughout the set mean the same thing. And we make a big thing in a lot of our rules defining project glossary and data dictionary. The reuse company did analysis and they looked at all of our rules. They included in a matrix which rules depended on that. And they also volunteered to write a new appendix that we can add to the guide that goes in law concerning glossaries and dictionaries. We mentioned it so many times it kind of makes sense to do that. Just patterns, so we have appendix and patterns.
One question on the point on overlaps. This question of avoiding overlaps to training, and it's better not to have overlaps.
Can you give an example?
You can have to deal with 2 requirements that deal with a need for 2 different perspectives, and on which you will have an overlap, but for the overlapping parts, there will be no conflict. And if for an overlapping on the, well, if we think a cause and consequence, if we have overlapping causes for the part overlap, if there is no conflict in the expected consequences, at the end there is no inconsistency. So it's not thing because there is this overlap. So we are doing the same thing 2 times, but avoiding and ensuring that there's absolutely no overlap is really constraining. And I'm not sure of the added value of making the effort to avoid discussion overlap.
Mike made a big point yesterday that our intent is not to make this the Bible, but you have to do it every day. We're giving you guidance. There's no shelf statements and none of these characteristics or anything else. We're giving you guidance. The intent is to get this into your culture and your processes. So the approach you're talking about, if it works in your organization, it's good enough. And that applies for everything in here, what works for you. And if there's no risk to the project because you're doing it one way versus another, then do what you want.
Yeah, I would think that implementing all the things that you're discussing and you're talking would be something you may want to do for an extremely large, complex system. But as you get into smaller and simpler systems, this is what we should do everything.
Yes, and that goes, I think, following all the rules. But the characteristics, and ask yourself, if my set doesn't have that characteristic, what's the risk to the project?
Yeah.
If my requirements are inconsistent, what's the wrong with that? If they're not complete, how's that going to affect my project?
I would think, implement, like I said, a subset of all the things that are, but you would certainly probably want to make sure you keep the whole thing about what,
So again, as we do, all of our products is going to be tailored. We're giving you the foundation, and then you use it however makes sense for your organization.
And I was posing the question because the question was on the table for our company, what to do with overlaps, going through the guide.
What was the end of the discussion? What did you decide?
To avoid overlaps when it's easy, and when it's reasonable to keep it because it has sense to keep it.
Okay.
So we can verify that there is no.
So basically common sense.
Yeah.
And that's all we want you to provide, common sense. There's some of the rules that applies to the common sense. And some of the rules we actually have a section called exceptions. If you could write up an example of that, others may have the same issue, and an exception for a rule or a characteristic.
I think I should be able to find example. When we do requirement modeling and formal consistency checking for formal proof on that type of thing, one of the points is to check that when there is an overlap, there is no inconsistent things. So I'm pretty sure that we would example of that. Starting with when it was right, but that's where we detected someone. Yeah.
The rules are also written for implementation by a requirements management tool. So the rules is rules. It's like grammar. Microsoft Word will check your grammar for you and put a squiggly line under it. It's up to you whether you choose it or not. So we've written the rules to be rules that the computer would apply, and then you can exercise some judgment about whether you want to ignore the rule or not. It's a bit hard to actually put all the exceptions into the rules so that the computer can apply them based on your judgment of risk and contracting circumstances and so on. So they are written in isolation, and in totality they may be a little large, but that judgment has to be exercised by the requirements writer, I guess. And the second comment I'd make is that Lou's use of the word risk is the appropriate thing for me. It's who you're engaging with, who you're contracting with, how you're doing it, and how you might write requirements for a sprint in Agile, for example, will be completely different to the way in which you might write it for a large, government adversarial contract. So rules is rules, but any exceptions you can think of, we're more than happy to write in. If you can think of a sort of a straight out exception where you might not apply it to something in a particular instance, we'd like to put that in.
Thank you. Conflicting needs and requirements lead to infeasible solution space, not identified early in development can lead to expensive rework. The transformation be formal would result in a set of needs and requirements that conflict or be consistent with each other. Even if individual needs and requirements are unambiguous, the inconsistent use of terms and abbreviations and units and measurement systems and different requirements adds ambiguity. And needs and requirements are inconsistent, conflicting with other requirements are definitely not correct. So they violate that individual correctness rules CA. And these are requirements that are inconsistent, conflicting with other requirements also result in a set of requirements that's not feasible, comprehensible, or able to be validated. Frequently, customer and other relevant stakeholder needs and requirements or design constraints each other need to be reconciled. So that's one of the points we're soliciting, and we get multiple sets of stakeholder needs and requirements. This project team's job is to address those inconsistencies. It may be that somebody's expectation, they have something with the example I gave with the doctor wanted to have a full hospital on board to the space station. And identifying link needs and requirements have relationships and dependencies with other requirements, either directly or indirectly. And this is really important when I'm allocating, say, some quantity from one level down to the other qualities. I introduced the concept of budgeting. If one subsystem changes something, it could conflict with another. And so if I link all those dependencies together, then if I make a change to one, then I can see what the impact is to the others, and I can keep them consistent. And there's a whole lot of performance quantities that flow down from the system level down to subsystems, down to system elements. So it's very important that we capture those dependencies, even if it's between different subsystems and system elements. And that's one of the problems we have in the document-based world. It's really hard to do that. In a data-centric world, where we have all the sets of requirements in the same tool, that's really easy to link those together.
Any sibling parent or sibling requirements?
Yes. And that's especially important in interfaces. So if my subsystems interacting with your subsystem within the tool, why don't I?
Like a shared ICD, for example.
Yeah.
Instead of.
So we're going to link together those. So you can't change your interface requirement without me knowing about it.
Yes.
You know? Well, we're pointing to the same definition in ICD, and that's one reason we do the ICD. So we're always pointing to the same thing, and then we can ensure consistency. And that's kind of foreign because we're so used to this document-centric approach, everything being managed in silos, the different sets and silos. But in a data-centric world, all those sets are managed within the same tool. All the interdependencies can be established and documented through linkages. So it's not just parent-child, it's sibling-to-sibling that you can establish those relationships. And when you come into change control, we want to maintain consistency through the whole set. This really helps in doing that.
I have a question. Do you have an example of the tools you use?
From an interface standpoint, go to our YouTube channel.
Okay.
There's a pitch I gave on there called Everything Went About Interface. It's great to ask. It's a presentation of the material containing the needs and requirements manual.
Oh, okay.
One of the interesting tests I had, other than the model-based system engineering question, is through the last year, about every single question people have asked me about requirements, I can point to the needs and requirements manual, right? He's asked me all kinds of questions. I keep saying, hey, this is what it said.
So there is still a pushback on, so I brought this up yesterday. One thing is pushback when using a document requirement that we don't have to discuss that. But other thing is ICDs in a requirement is not something I think that they would not. It won't be submitted to FDA. ICDs.
ICDs won't.
Yeah. That.
I couldn't hear you.
He said that they won't, the ICDs themselves, they won't submit to the FDA.
So, yeah, and the med device will, as part of the DHF that you submit to FDA,
Interesting.
ICDs.
I think you get a 483 in that.
That's like we don't do basically where and we quickly abstract when you are in requirements in detail for things like shared failure status on the framework, many parameters. And on one case, you will do things in scenarios thinking that when you lose a parameter, you will put the new status, but you just forget that you will lose the other ones, and you will have example of inconsistency where it could be to on our.
Yeah, I think
And I find one of the biggest issues in the inconsistencies.
yeah.
And so the FDA wants the objective evidence that you have met all requirements. And so for you to show the evidence, you're gonna have to reference what the defined interactions are. And they're in the ICD. So I don't know how you can know that you met the definitions in the ICD if you don't include the ICD definitions
Exactly.
in your set.
And you
But
are,
the way the system requirements currently written, they're not in the ICD reference one. They just wrote it. They wrote the interface requirements as system requirements, and now I read them. 70% of those system requirements are actually qualified interface requirements.
Okay.
The syntax and structure and rules, I would like the team to adopt that, but there's a pushback right now. It's a lot of overhead.
So what does an interface requirement look like?
yeah,
Your
give us an
document.
example, I'm just curious.
Like more, they use the verb incorrect. I think more of a subsystem A interacts with subsystem B. Period. That's it. and there's a
Yeah,
data
with no
exchange
definition.
happening, like receive. These are states, and okay, the statement of facts, which is what your ICD or
Mhm.
they write that as a requirement, and I'm asking, why do you verify in statement of facts? They should be
Exactly.
defined of.
Exactly.
What you're verifying as part of your interface requirement is you actually use the pointer. You're calling a document to say that whatever is written in that document, there is a send and receive interaction. That is the one that needs to be
And
captured.
what you're gonna do if, for example, the same system have like another base with it, and each one of them is constructed by a different subcontractor. So it's kind of interfaces in one.
Yeah,
Yeah,
it's like
nice.
a game of chess. The mistakes are waiting to be made. Do that, yes.
Unless you guys gonna communicate. Wow.
The idea that interface requirements or function requirements was very important because we said every function requirement is incomplete without including the performance piece of it, right?
And the condition sometimes.
Yeah. In the case of interface requirements, the performance piece we've put into a different document, ICD, because if we have two people interacting with each other, we want them to point to the same definition, the same performance.
Right.
We don't want them to individually define different performances, or they're not going to be able to interact with each other properly. The ICD is just a way to manage consistency between all the parties.
So what's happening is we don't have owners of those ICD documents. If there are owners, it's not very well maintained. But that could be a reason.
I the same issue, and I think we find that in many of the point for me is that ICDs are not required. They are a design description or architecture description. And the mismatch is that people considering that the ICD is a requirement in this, which is behind that. And that could lead to significant impacts like I'm making a braking system and to ensure the non-blocking of the wheels, I need to have the aircraft field. And so my ICD says, send me the aircraft field. Point is that he missed the point that what's the range of use, what's the precision we need, and they missed the need. And at the end, creating with all the wings deployed in 20 seconds. Okay.
And the section on interfaces, I have an interface audit. And it's scary as heck. That audit and find out how broke they are when it comes to interfaces. So that's all described in the needs requirement plan and also in the channel presentation on interfaces.
And on the question of consistency, on that point, I think which one is the digital engineering with the digital viewpoint model, on which say that at the end it's viewpoints on the same digital artifact, and you have to ensure the consistency because it's describing the same thing. So requirements is a viewpoint, functional expression of what you expect is a viewpoint. Your scenario is a viewpoint, and those viewpoints are sharing common information that will be consistent. And then you can draw the parallel with the ISO 4210 and the fact that you have to define what are the correspondences between the architecture description elements and the correspondence rules in the to check. I really think that it's under also by the
And one last thing about interface requirements that they're actually paired.
Yeah.
Yes.
You can't have one.
It's pairs in the case where systems being developed concurrently.
Yeah.
In the case where you have an existing system that's already built, have an ICD that sets the rules and says, you gotta play by my rules.
Exactly.
It may not have been known about your system when it was built, but it was built to allow you to interact with it.
Yeah.
So in that case, you'd have an interface requirement, you're gonna interact with it for its rules. So moving on, a big thing using modeling, diagramming tools is really have consistency. And also having that defined the glossary, data dictionary is gonna help as well. This is one place where the natural language processing AI tools are really good. Tools like are developed by the reuse company, their tools depend upon the glossary. So if you use a term in one requirement and it's not consistent with the glossary, it's going to flag that. So it really helps with consistency in that. And we just talked about interface requirements. We have a lot of rules, like I say, that help us with consistency and attributes. The traceability will help with that. Odd activities contribute to consistency within our document. Correct is the new thing we're talking about. Sets. And so we want the sets to be an accurate representation of the concept of sources from which it was transformed. Has a set, concepts. So we want the integrated set of needs to reflect that whole set lifestyle that apply to our system that we're engineering. Because like I said, a lot of lifestyle concepts may deal with organization and not the product. Set of requirements must be an accurate representation of the need sources. So again, accurate representation of the set of needs from which the set of requirements came from. There's a correct set of needs implies no errors, but the inclusion of incorrect information and again the omission. So this is an avoidance of incorrect individual need statements. If we have individual statements that are incorrect by definition, our whole set is incorrect. Again, it's really hard to tell what's missing from a set. The tools definitely can't tell you that. So that's one reason why it's important with activities. So all the activities that we define in the needs and requirements manual is really to help with the consistency, correctness, and completeness. The same kind of thing for a set of requirements, no errors, and so on and so on. Set of needs, and the set of needs and requirements cannot be corrected if you don't have those other characteristics for sets. There's a lot of overlap between all these characteristics. Validate the integrated set of needs reflects an accurate and unambiguous interpretation of the concepts, stakeholder expectations, progress constraint, of the problem of opportunity, of any models or diagrams used for analysis from which these came from. So all this is going to help us. So we got to think about the validation. Did they really communicate the sources? The same with the requirements, accurate, unambiguous interpretation of the needs, sources, higher level requirements. They were transformed the models and the underlying analysis. So we talk about needs validation. I showed this for the individual ones, but we're doing this for the whole set as well. The same with requirement validation. We did this for the individual requirements, but we also are doing this for the set. So the last three that we have is the agreed to obligation. In the end, like in the contracting world, it's the set of requirements that's being under contract. So what characteristics would you expect that set to have if you're going to sign a contract? So we're saying, well, everything in the set as a whole needs to be feasible. We need to be able to clearly understand what it is you want us to build. And we need to be able to validate that the system that set meets the needs with it represented. So feasible set of needs requirements is feasible if it can be realized within the constraints, cost schedule, technical, with acceptable risk. Just as a little point of green, the obligation for individual need requirements, the same goes with the set. If it's not addressed early in the development process, it can lead to wasted effort and cost. Again, that's always bothered me, is how do you establish feasibility and set of requirements if I haven't done the assessment before? And that's one reason why we're emphasizing needs, is we got to get stakeholders aligned on the needs and make sure what they say they need is feasible. And then if we do that analysis, then the resultant set of requirements should be feasible. So that really puts a lot of emphasis on the customer in a customer-acquired relationship. The customer is equally responsible for doing good systems engineering as it is the suppliers. A set needs to be feasible if individual, and if not feasible in the state of constraint with risk appropriate for that life cycle, the set needs will not be feasible, nor the resulting set of requirements transforms those needs. And set requirements may not be feasible due to inconsistency, physical impossibility, or excessive risk. While individual requirements may be feasible, they may not be when placed in combination with the others. And so that needs to be a problem. How do you know this whole thing about the one match that breaks the camel's back analogy that we have? When do we know that happens? So it can get a little bit of a problem in that, but even though we've done the individual needs feasibility, break the bank, feasibility was unless we determine the context of all needs for a specific entity and staff and can be evaluated without sources to which they were derived. Needs within the same entity set can be analyzed together with respect to program constraints and technology maturity, determine feasibility. Before allowing the set needs to be baseline, assessment feasibility of the chosen lifecycle concept should be made in terms of drivers, constraints, and risk. Feasibility is the key thing that we're doing during the lifecycle concept analysis and maturation is key consideration. And if we can't find a feasible concept, then we're not ready to define a set of needs. We can't think of a concept that is feasible. We're gonna have to go back and reevaluate the problem, go back to some key stakeholders and say, hey, we just can't do this. Set requirements for the same entity are analyzed together, just like we did the needs. And the measure of feasibility is not always easy to access, like we talked about before, during the degree of risk. And so we want to end up with a bucket that can be done within cost, schedule, technology, and with an acceptable part of risk. One way of measuring that, I include the thing on here with reserves and managing risk. We mentioned some techniques that could be used in the whole concept of reserves and margins in project, coming by determining feasibility. The comprehensive is a set of needs and a set of resulting requirements must be each written such that it's clear as to what the expected entity and its relation to the macro system, which is the part. Given that set of requirements, there should be no question as to what's expected of us. What are our overall expectations? If we can't understand what that is, then there's a problem. An agreement's difficult to enact unless both parties are clear of the exact expected outcomes. So we got to write things such that the relevant audience can understand what's being communicated by the individual as well as the sets. And then the relationship of the other characteristics. So information needed to understand the context should be included within the set. And a data-centric practice would be easier for architects, designers, builders, and coders and testers if underlying analysis, including along with the set of needs and requirements. So the modeler, and you have really good models that result in a set of needs, and then you use the models to help you transform those needs into requirements, and then you provide that set of requirements to a supplier. Why not supply the models too? All that analysis, because then they can just build on that as they progress cycle and design, and they can develop simulations, but they don't have to reinvent the wheel. I don't know if the contracting world ever allows us to do that. But if we're developing products in-house, that should be the standard mode of operation. Is that the model is passed across the life cycle. And the problem with that is when you're in silos and you have different groups and they want to use different tools, and different techniques. And that's why we want this integrated collaborative project team that's operating the same models and the same integrated data set that we have for our system. And that's a really advantage of having data-centric practice in system engineering where everything's managed within our databases. So then we can have an authoritative source of truth across the life cycle. Using integrated collaborative multidisciplinary project team, the development process activities really helps. Coordinating with getting an agreement and giving feedback will really help. So if find that set of needs, we want all the downstream stakeholders to be involved in that baseline. And if they have any questions to understand, then we can fix that before we baseline in the same terms. And so we need to have a well-defined baseline process for these stakeholders to ensure this, and continuous validation artifacts across the life cycle always helps. Why we don't want to wait to the end to do validation. We're doing continuous integration, verification, validation across the life cycle. And comprehensibility of the set of needs and requirements to be assessed early, like I said, during system verification. And then able to be validated is our last one. It must be able to be validated, integrated set of needs will lead to the achievement. So just like individual requirements, we said we're verifiable and validatable. We're just saying the same thing for the set. So I kind of skip through some of this real quick. We want to make sure that we are doing this validation and continuous part of it. We have checklists in the needs and requirements manual and checklists in the guide to needs and a whole lot of questions that will help us all these different characteristics. Talking about by going through these questions will help. And this is for the set of needs, for the requirements, similar set of questions. We don't have time to go through each one of these. It just helps you and to ensure that you met all these characteristics. Planning process. That goes through all that. I'm gonna go through real quick dependency, and then we'll talk about future of the guide, and then we'll finish. Cross-reference matrices. This is a new one that the reuse company did when they were reviewing this. They made the observation that when we look at all the rules, some of them fit for both needs and requirements. Some of them are more applicable to requirements, but not as to rules. You look on the top, it's kind of hard to read. So they have a CNR, compulsory for needs and requirements, RNCR, recommended for both needs and requirements, and then compulsory for requirements and not applicable to needs. So they went through and did all this assessment for us. And then they went and added the column second to the right, rules scope, requires project data dictionary. So some of the rules are dependent upon you having especially for that consistency. So that was really nice that they've added this. So we've added this in here. And then we have matrix that maps all the rules to the characteristics. And then we map all the concepts and activities from the needs and requirements manual to the different characteristics as well. There's 2 pages of that. So the next steps for version 4, we're working on TPP.
Technical product plan. Mike
typo on my
has
part.
a draft of that already.
Right, so it's typo on my part, I'm sorry. But we got to finish that. Trying to have another round of reviews. And right now we have it's ready for review. So we'll come up with a schedule of that, asking for comments back on this new version.
He's gonna reach out by email, or you're gonna put it in the end, or how that around.
We'll announce it in the email and also on the Yammer. And pointer to where the document is, and also to the comment form used. Appendix C hasn't been done yet, but it's going to be up. It was written 4 or 5 years ago, so there's some room for improvement to read. Instead, we're talking about adding new appendix for ontology glossary and dictionary, because it is mentioned multiple times, and we thought it'd be helpful, you know, to do that. Our focus right now really has been on section 1, 2, and 3.
Sure.
And we have done a bunch of updates in the rules. We've done a little bit of work on the examples to improve their quality, but there's a lot more work to do. And then the question mark is what other things are going to come up that would improve the value of the guide. So we've made a lot of progress, a little bit more work to do. But as soon as the TPP is all done, we have the schedule down and everything. We'll communicate that to y'all. The review cycles. I think Mike's got included in the TPP at least 2 more review cycles, and they're submitted for approval. And then then tech ops has a role, Marcom has a role in the marketing stuff, and then it'll eventually be released to be put into the store. So that's the end of what I was doing. I really want to thank all of you for your participation. It really makes it to me worthwhile for IW when we can have these discussions just around the table, all the clear ideas. I really thought that went well the last 2 days. With that, Tammy.
Yeah, I again want to reiterate my thanks for everyone joining us, both online and it's been great having you here. Sorry to step in and out there. Had to divide and conquer a few sessions that were happening in parallel. But we really appreciate the working group members who want to contribute, want to ask questions, want to challenge what we're doing and make sure that we're thinking about all perspectives. So the conversation doesn't end here. What we are going to do is put things out, feedback, please mark things up, let us know what would help make it better. We are going to have our monthly meetings start up again near the end of February. We've already gotten some great suggestions on talks and up. We are going to keep the Yammer community going. I hope I saw a few social posts even while we were here. So please consider that a resource for reaching out to folks who may have solved problems you're trying to solve. Please continue to use our Yammer community. Our INET page is getting loaded now with these slides. So if you wanted this material, you spend time looking at Lou, reviewing it, you want to go back someday, check our INET site out. So again, thank you. I really appreciate all the support we've had.